an artificial gravity generated technology. Now, how does this technology work? I've read some of the articles on Wikipedia, and these are some of the articles that I got from Wikipedia. So it's actually a pseudo-gravity that's the creation of initial force that mimics the effects of gravitational force, usually by rotation. That means if it's like a station in the center, it has to be in the center here, and then there's something that rotates around this station. Now you can see it in motion, right, as I shared with you. So it has to be this center, and then something rotates around it. There are some. It's not so easy to actually create this, and there's no actual station that was created in space for this because of the engineering challenges and also some difficulty that they face. Now let's go to and read on to see the difficulty. So it's centripetal acceleration. So there are no okay. But before we go to that, let's go to the amount of artificial. Depends on the linearity of the radius. So depends on the, for example, the velocity of the speed of it as it spins, and if the radius of the spinning centripetal force is not long enough, you'll find that actually the person will feel a bit dizzy, because he will feel that actually his head is heavier than his legs, or his legs are heavier than his head. So he might have this problem here that he faces. So it's either you make it slower or you make it bigger. So it has to be at the right amount. So this is also not easy because you need a lot of testing on Earth to actually get the correct amount. So problems may occur. So let's say it's spinning in one direction. So if you move in the other direction, let's say in the spaceship move in the other direction of the spinning centrifugal force, if you move in the opposite direction, you may feel dizziness, nausea, and disorientation. So this is what will happen. Some of the things will happen. So how are you going to overcome it? So you need to have, this is from Wikipedia itself. So you need to have a propulsion system. You need to have a lot of elements involved. You need to have a lot of mechanisms. You need expendable propellant. You need expanding mass, electric motor, counterweight, reaction wheel, another living area spinning in opposite direction, so that you can actually counterbalance all the momentum and all that. Because if space is like weightless, you have to have something to counterbalance it, because you keep moving in space. If it spins in that direction, you need to have something to counter the movement of it, so that it doesn't keep moving. So this is one of the so it doesn't like shift away from certain positions, and you can control it properly. There's also other engineering problems associated with it. You need to have extra strength, and then for the structure, and it's very modestly there to have 10 tons per square meter at 1 atmosphere. So this is the strength is needed, but for current like structures, it's very modest. So I think it's not so easy to actually create this sort of structure as well. You need to have a certain sort of like a combined material to actually make it stronger and then more durable in space. Actually, there's this video that I created on space. It's aluminium. It's an aluminium and mixture of other metals that actually make it possible for it to be in space. So additional energy is required for countering friction when other parts of space station is not moving. So there's another issue. So the artificial gravity technology is not so easy to be replicated, because there are a lot of issues you must think about, like the friction. You talk about technology, you must counter the friction as well. There are a lot of engineering methods you must do. So you need to counter the friction with more additional energy. You require vacuum tight axial seals. The seal is a seal that is vacuum tight between the spinning axis. So you have to be airtight. If you get leak, what happens if you get leaks? Now you have to go and fix the leak, right? So if one just go off, maybe it might make a chain reaction. So you must be careful. You must be always vigilant to see if there's a leak that happened and then fix the leak. So this is like the artificial gravity. Has there been artificial gravity missions involved? Yes, there is. According to there are actually a number of proposals that have been done. According to this, let me go there. There is actually, using Discovery 2, a 2005 vehicle proposed capable of delivering 172 metric ton crew to Jupiter orbit in 118 days. A very small portion of the 1,690 metric ton would incorporate a centrifugal crew station. So they actually did it already. There's actually, although they say that there's none, but then they incorporated a vehicle. So there's multi-space mission. He proposed for a long-duration cruise space transport, including a rotational artificial gravity space habitat. So they actually did it as well, to provide 0.11 G to 0.69 G in built with a 40 feet. So there's an ISS centrifugal demo that actually was created as well. So it's a test and evaluation. There's a Mars Direct plan that will carry astronauts to Mars to join previously launched Earth return vehicle. So there's Tempo 3, there's Mars Gravity. You can actually read up all these missions that have already been there. But this Mars Gravity via satellite wasn't successful because it was cancelled on 24th June 2009 due to lack of funding and shifting priorities at NASA. So there are a lot of issues with implementation of this artificial gravity, but artificial gravity is the core of this this space exploration, because if you actually read the top of this article, right, they talk about this health effects caused by prolonged weightlessness. If you click on this article here, so there are negative effects like include muscle atrophy and deterioration of skeleton and cardiovascular system, decrease of red blood cell, balance disorders, eyesight disorders, changes in the immune system. It has a lot of health issues for people who are traveling in space in weightless environment, because I think our bodies are used to the 10 gravity 10G kind of weight force. So if you go to a different environment which is weightless, it will be a shock to the body, and then a lot of effects, a lot of bad side effects. So this is the current technology, and then this is how important it is to keep our astronauts healthy, because they are trained for many years, and then they are actually the cream of the crop for space travel. And I would say that to take care of them and then retain the talent for these space travelers, it would be very important, because they can bring back their experience and knowledge and teach other people, and then they can also carry out space missions that will help humanity to understand more about space and space travel, and then about the conditions in space as well. So we need to actually overcome all these engineering problems. I think it all can be done, as well. As you see, there are many problems associated with it. So before we end, I'd like to share with you this GIF file. This is the GIF file where it's actually rotating. As you can see, it's actually rotating, and then this is the center part where actually they will be all be like moving around, and then will be inside the space station doing their matters. So this is the ball will be just moving, and then this will be what they will have to actually fix the centrifugal part also, so they will actually be there also. So I think that it's inevitable that this system moving in this manner would actually be a fruition in the future. In the future, it will be easy to create a artificial gravity easily because of the advances in technology, and they are testing different sort of they're actually implementing it in different space missions already, as you can see from this Wikipedia. Please read the Wikipedia article below, and then I thank you for watching. Please subscribe to my channel for more updates, and I'd like to leave your comment if you have any thoughts on this artificial reality. Thanks for watching. Bye bye.